Good morning. Today I want us to look on the effect of forces when it acts on a mechanical object. And I would like us to be going through a series of sessions which I'll be sharing with you online. And within that I'll be giving out assignments. Kindly make sure you do them and also be attending classes so that by the time we finish this session, at least you'll be able to understand. So by the end of this session, I expect you to be able to define what are forces, a stated unit, and also be able to describe tensile, compression, and shear force, and state their relevant practical examples. Also, I expect you to be able to calculate mechanical stresses and evaluate failures associated with it. So this session of ours, I shall be able to deliver it online, so that I'll be giving timeline, so that you'll be visiting my YouTube channel and you'll be able to be seeing more and more of this. So you shall be watching videos. I'll also be uploading some other videos and assignment. I will also attach some links so that you can be able to get more information. So when we talk about force, force actually can be defined as a push or a pull, and the SI unit for force is Newton. Force actually is an influence that can also cause a change on the state of an object. It can make it move, change its motion, change its shape, or even changes structural structure. But for example, if you are pulling a box, like the way you see this guy here called Bob doing, he is applying a force to pull the object to move along the point by which you can see is pulling. So the lobe will be exposed to what we call tensile force, and sometimes this load is having a resistance to move because of something we call frictional forces. But we shall look them into detail as we move on. All these are type of forces. When you compress an object, we say that are compression forces. When you stretch it out, we call that tension forces. We have shear forces, we have torsional forces, and we shall be able to look all of these in details as we move on. So let us look at the effect of force on a mechanical object. And I have said, as I said earlier there, that a force will make a change in the shape and the size of an object, and this change can be either bending, twisting, breaking, shrinking, fracturing, and it can also maybe lead to change in motion. It can make an object start moving or stop, accelerate, or even decelerate. But this time I want us to concentrate more on mechanical properties on an object. That is tension, stretch, compression, and torsion forces. And we shall look at those three, and we shall start with the tensile force. And I said earlier that tension is a force that tends to stretch a material. Maybe like a rubber band. You see this guy, when he is stretching a rubber band, then that rubber band is exposed to tensile force, and it is at a tensile stress. Also, a spring, you can be able to stretch it out, and then it will be exposed to tensile force because it is stretching a material outward. An example is a rope or a cable of a crane, as you can see, a rubber band, or even when you are tightening a nut using a spanner. Compression force is opposite of tensile force. This one tends to squeeze or crush a material, like a pillar which is carrying the weight of a bridge. When the car moves on the bridge, and also the weight of the bridge, they will kind of expose the pillar to a compression stress, a compression force, because it stretches the pillar downward. Also, when you are moving, when you are walking, your weight will tend to compress the sole of your shoe, and then we shall say the sole of your shoe will be under a compression force. Also a jeep, as you can see, this member K will be exposed to compression force because of the weight by which this jig you can see here will be lifting. Shear force is a force that tends to slide one face of a material of an adjacent face. An example is a rivet holding two plates, and also a guillotine cutting sheet metal or a garden shear. And also a horizontal beam is subject to a shear force. So there are very many types of shear force, even transmission joint when you come to automobile. So force actually will introduce something we call a stress, so that a material will tend to change in shape. These changes sometimes you cannot be able to see them with your naked eyes, and sometimes we need to calculate something we call a stress, because when you expose a material to a force, it undergoes some changes, internal changes, which you cannot even sometimes see with your eyes. Then that's what we call a stress. And a stress, we say, is a ratio of force applied to an object to cross-section area of application, and it is given by F over A, and A is area and F is force. An example, we can say if a rectangular bar having a cross-section given of 75 millimeters squared and has a tensile force of 15 kilonewton applied to it, when we want to look for the stress in that object, sometimes we may not be able to see with our naked eyes the change in the length of the object, but we can be able to calculate it by applying the force F over A, and when we do that, you'll be able to see that that material will be under compression, under tensile force of 200 megapascal. So, having known how to calculate stress, you can just try and calculate the stress of these exercises I'm given here, and also be able to follow this YouTube channel and be able to do this exercise and submit it through my email, so that I can give you guidance and I can be able to correct you. So let us see you next in our next session, which I'll be uploading very soon. Thank you, enjoy yourself, and continue learning more about forces on mechanical object. I'm George. Thank you very much.